Welcome everyone to this very special webinar. We're so happy to have you. And Sarah, it's always good to see you. Thank you for joining us.
Thank you for having me today, Mark. It's great to see you.
Yeah, likewise. Well, we had so much fun on Voices of Video, and of course, we had a great time at NAB talking about VPUs in the cloud. That uh, I think we both agreed in about 3 seconds. Like, we need to do a webinar, right?
It was a definite instant decision.
Yeah. There was
Have that
no discussion needed. Like, of course we are.
definitely.
Well, it's great. So I'm going to go ahead and launch in here. So first of all, for all of you who have joined us, again, welcome and thank you. What we're going to do is I am going to take a couple minutes and talk about NetInt, talk about VPUs. For those of you that know about us, don't tune off because you definitely want to hear what Sarah is going to be presenting about Akamai's support for VPUs. And for those that maybe have heard about us but don't, aren't too familiar, well, then here you go. So with that, Sarah, we'll catch up with you in a couple minutes here, and let's go ahead and launch in. All right. So VPUs in the cloud, and this is obviously what we're here to talk about today. But first, if you're not familiar with the VPU is a category that we created, NetInt created 10 years ago now. The company was formed in 2015. And we really were built on a couple premises. You might even say a couple ideas that led the pathway to building the VPU category. And the first is that we conceived in 10 years ago that as video codecs got more complex, the notion of running software and CPU was going to just be unsustainable. So, when we went from H.264, from AVC to HEVC, H.265, the compute complexity, out of the gate was nearly 10 times. And obviously, over time, as open source, particularly like X265 and other commercial versions were optimized, then that falls. But still, HEVC today carries easily a 2 to 3x compute complexity. And then when we went to AV1, for goodness sake, some of the early implementations of AV1 literally required 20 or 30 machines running simultaneously. And that wasn't even to get live performance. That was just to get some sort of performance that didn't take days to encode, even a 10 or a 20 or 30-minute clip. So we saw this 10 years ago, and we knew that the only solution was going to be custom silicon. It's commonly referred to, it is referred to as ASIC, that's application specific integration circuit. So we took that revelation, if you will, and combined it with the idea of using NVMe. And NVMe is the storage protocol that your SSD hard drive, whether it's in your laptop, in your desktop, or in the data center, that communicates to the host machine. NVMe has a lot of massive advantages. One is it's very fast. This is the memory bus. The second is that as long as a server, as long as a computing platform supports NVMe, there's no drivers required. And this, as we all know, if you've tried to integrate GPUs into your workflow, you know that getting the right compatibility of OS, getting the right drivers, getting the environment, the software support systems of the hardware is very difficult. So these two innovations came together, and now for the last 10 years, we're really proud of the fact that in 2024 we actually won a Tech Emmy alongside Google and Meta, and that was a result of us being first in the category. So the chart on the left there just shows in 2018 we launched our first generation product. Our second generation product called Quadra came out at the end of 2021, went into commercial deployments in 2022. Meta launched their first chip in 2019, and that was for Facebook, Facebook Live, and then obviously Instagram, and then Google for YouTube launched in 2021. So this is the foundings of the company and the genesis of the VPU category. So the question that you probably have is, okay, I've been hearing about VPUs. I certainly know about CPU. I know about software running on CPU. That's what pretty much everybody's doing today. Many of you might also have migrated some of your workflows to GPU. It's very common for live HEVC workflows to run on GPU. And so what's VPU? So let's take a really quick look here at the differences between these architectures. And I think the easiest way to sum up the difference between like CPU and GPU is the same CPU that we use to encode our video streams and to create transcoded packages that we then deliver, to our users. That same CPU, excuse me, is used to run your ERP system. It's used to run your accounting system. It's used to do any general compute task in your business. So that's a benefit in that you can take that machine and you can redeploy it to do lots of interesting things. The drawback is that it doesn't help us as video engineers. There's absolutely nothing that is optimized for video encoding, video decoding, video processing in the CPU. Excuse me. And that is where the GPU starts to become very interesting. First of all, the GPU is a totally different architecture, has thousands, even tens of thousands of cores in it, a lot of compute cores, very high compute density. And most GPUs, and this is changing, which I'll get to in a minute here, but most GPUs have a dedicated area on the silicon that is hardwired for video encoding, some even video decoding, different video functions. And it's about 15% of the chip. So the advantage you get is you go from a general purpose with zero surface area dedicated to video to GPU where 15%. And then you go to VPU and now you have 100% of the silicon surface area dedicated to nothing but video. So going back to GPU, one of the big challenges the industry has right now with this particular category is that all of the chip vendors from NVIDIA on down, doesn't matter who's in the GPU business, they care about one thing and one thing only. And if you don't believe me, just go listen to any of their quarterly earnings reports, go read analyst reports. They care about AI inferencing. That is it. That's great for those building large language models, self-driving cars, etc. It's not good for those of us in video. So the advantage with a VPU is not only is it 80% more energy efficient, meaning that literally if you have 10 machines in your data center, currently, let's say CPU based, running your video encoding operation, you could remove 8 of them, maybe even 9 of them, and do the same amount of work. So you save tremendous amount of energy. Obviously, you're cutting your CapEx. You're, of course, cutting your OPEX. Now you don't have to power those machines, or you simply have machines to redeploy elsewhere. So I've touched on this already, but I think it really is important to point out. And the question, we're now 5-6 years into commercial deployment, so VPUs are not exactly unknown, but we still find that when we start a conversation with someone interested in adopting the technology, the architecture, the question always comes up, okay, this is still a relatively new category. Is it going to last? Is it going to be here? Is this something that I can really trust that if I invest in it, invest in this hardware, that, it's going to be here 5 years down the road, 7 years down the road, 10 years down the road? The short answer is yes, you absolutely can be assured it will. And we really like pointing to, again, Google and Meta as their entire video operations run on VPU. Now, that does not mean that they, don't have software running in various places in their systems. They absolutely do. There's certain codecs, some of the newer next gen codecs that, just because the chip support isn't there in their chips, that they're running in software. But the vast majority of video that you watch on these massive platforms, arguably maybe the largest platforms in the world with YouTube and then all of the Meta properties, is being encoded, it's being transcoded on the exact same technology, not our chips, but the same technology, ASICs, that we have deployed. So you can have a lot of faith that this technology is going to be there for you. So let's take a quick look here as we think about now, okay, Mark, I get the advantage. So this is great. This sounds like the engine that I want in my car. But how does this work in practical application? It needs to go in a host server. So where do things like decoding of maybe some unusual formats? Our chip is very capable, but we don't support MPEG-2 decoding, for example. We do support VP9, we support HEVC, and we support H.264. So what do I do if I need to be able to bring in MPEG-2, and what if these are interlaced streams? Now, for those of you who are dealing with progressive video, internet video, you're not bringing video down through broadcast, from satellites, et cetera, then you might say, what is he talking about? Is MPEG-2 even around? Yes, it's around. And yes, interlaced is still very much a thing, as much as we all would love for it to go away. But this is a great illustration for how the marriage of the VPU running inside a host machine with very powerful CPUs provide the ultimate transcoding engine. And so what that would look like is on the CPU, on the general purpose compute cores, now you can run FFmpeg, you can run GStreamer, you can run GPAC, you can run your commercial or your third party, transcoding framework, media processing framework that does all the packaging, does the DRM, might do decoding of codecs that are not supported in our VPU, can do deinterlacing, can do all this on the CPU. And what the VPU then is able to do is the super compute intensive functions of encoding AV1, encoding HEVC, encoding H.264. So this combination actually is where the real power comes. And that's why we're really excited. This story of VPUs on the cloud, on Akamai, on the Akamai Connected Cloud. This is really powerful because as Sarah is going to talk about here in a couple minutes, now you have the ability to operate a machine that is fully performant in both areas that you need it to be. You can run the software on that same machine and do the video encoding on the same machine. No longer do you have to have this sophisticated orchestration layers because you have one machine that is doing packaging, you have another machine that might be doing some other part, scaling or some other part of your workflow, and then you've got yet another machine that is creating your ABR ladders, doing the encoding. Now it's all on one machine. Very powerful. So I know everyone loves numbers, and I do too. In fact, we really our data is very well known. It's tested. It's proven. The numbers that you see here are not models. These are real world numbers. Really, all of the data that we show comes from customers. So you can be assured that what you're looking at here is real world. And I thought it would be helpful to look at two different scenarios. Now, there's really three scenarios here, but there's sort of a scenario 1A and a scenario 1B, and then a scenario 2. And what you're looking at here is 100 HD streams run 24/7, and what that cost would be over a 3-year period of time if you were to, in scenario 1A, if you were to go to AWS and if you were to use a Graviton instance. Now, this is, we wanted to weight this as much in the CPU's favor as possible. So this is H.264. We didn't even calculate this with HEVC. And if we had calculated this with AV1, like the amazing thing is column 3, the numbers stay the same, but columns 1 and 2, literally, 3 to 4x go up to like 10x in the case of AV1. So, we're trying to give the CPUs as much advantage as possible. So if you went to Graviton, which is the lowest cost, most efficient instance for, if you just want to say kind of bare bones video encoding, Graviton instance, the cost to run those 100 live streams 24/7 would be $311,000. Okay, $311,000. If you were just to run a more standard compute instance, an x86, that price goes up. But $311,000. Now, you might say, okay, Mark, we know that because, we used to do that. But guess what? We got smart and we figured out that actually, if you're able to buy right, and if you're able to, find the right colos, you can negotiate some pretty low cost colo space, and you can build machines fairly inexpensively, and you can cut that bill down. And you're exactly right. In fact, we have a lot of customers who have gone this path. And so this same workflow could then be cut to a touch under $200,000. Very, very nice savings, incredible savings, really. Like, wow, that's very meaningful. And that would be, again, CPU only. That would be, you go out, you find the lowest cost machines, you find the lowest cost colo, you basically run it yourself. Then you say, okay, but what would happen if I ran that same workflow, everything required for those 100 channels? What would happen if I did that with VPU? And here's what it does. It takes the price from $311,000 to $193,000 to $47,000. It's an 85% savings. So this is the kind of value that we're talking about. And Sarah's going to be sharing also some data and some numbers with you that are going to be, extremely eye-opening. So we just talked about data centers, right? We talked about comparing the cloud. We talked about maybe running our own colo. And I'm going to assume that everyone's here basically saying, hey, I don't run my own hardware. I don't want to go strike deals with colos. Or maybe you are and you're like, we really do want to kind of get back to the cloud, but we just simply cannot go back into the traditional kind of cloud infrastructure, kind of the hyperscaler type infrastructure where the cost just, the scaling never ends. It's unsustainable. So what about the cloud? And this is where I want to bring Sarah up and have her talk about what Akamai is doing with VPUs in the cloud. And with that, Sarah, take it away.
Thank you, Mark. So, what about the cloud? To your point, I'll start us off with a little bit of information about Akamai's kind of mission statement for media. To put it briefly or a little bit of a different way, Akamai is trying to build the leading cloud for developers to build and deliver and secure their powerful streaming workflows. You might have heard of Akamai, but in a CDN context, as a CDN provider. We now offer a full suite of compute and delivery and security products used by some of the largest media organizations in the world, as well as media technology partners that work with more traditional media organizations to provide specific services, including many in our sort of partner ecosystem. So we have what we call a continuum of compute. For our computing platform specifically, we have sort of three tiers. Our infrastructure core, distributed, and edge. So you can design your custom deployment and leverage different types of locations and cloud computing services to scale your applications or increase overall performance, or to deploy additional infrastructure close to your end users. For now, VPUs are part of our core infrastructure lineup. So I'll focus on that specifically. And we do find that the core is where the majority of customers are deploying their sort of heavy duty or resource demanding infrastructure. So we really view our offering, again, as sort of a full stack media cloud, where we're trying to service customers across this entire continuum, whether that's locations or their entire workflow. And the combinations of these solutions, we feel, provides customers an opportunity to deploy a comprehensive end-to-end stack of solutions running on our cloud. But when we were thinking about the actual transcoding work, we saw a lot of area for improvement. As Mark touched on, CPUs are not optimized for video. They're general purpose. They're not built for parallelism or the throughput that media workloads require. And live workloads really demand real-time responsiveness. Delays in AVR ladder generation can impact video quality, increase latency, or trigger buffering, especially with variable networking conditions. Scaling gets very expensive, and transcoding competes for compute. As Mark touched on, it runs alongside app logic and caching, and that can create unpredictable performance under load. We've been having conversations with media customers over the years, and recently over the last few, we noticed a trend where we had customers who were adopting NETINT VPUs on-prem. We realized at that point we had a lot of mutual customers and a really great opportunity to make VPUs available in the cloud for the first time, both for our mutual customers and other media customers who were interested in trying them. We think Akamai is kind of unique in how we're trying to make the cloud work better for our media customers. We've had over a 25-year history at this point of evolving with these customers, first as a CDN provider and then into security, and now with the cloud. And we're developing our cloud to build on that history as a CDN. And kind of one of my favorite points is, unlike many of the hyperscalers, we are not competing or trying to compete with these customers. We don't have an Akamai studio or business ventures where we're looking to create content or house our own media streaming application. We are doing what we do well, which is to support the interests of these media customers, especially as we see the interests of our competitors moving kind of in that same direction. So how can we use this combination to drive efficiency with NETINT VPUs? These are built for video, so they're really up to 10 times faster in our testing that we've seen than CPU for real world workloads. One VPU can power 15 simultaneous live AVR outputs, and that translates to massive cost savings. Comparing to the VT1, so that's the AMD-based media accelerators offered on AWS's EC2 platform, the cost savings are really almost incomparable, and especially when you account for egress costs, which I'll touch on a little bit more later. And one thing that I also like to point out is that unlike many of the other solutions for transcoding in the cloud, VPUs are sustainable by design. Each VPU uses about 17 watts or half a watt per 1080p stream. And lower power means less cooling and a smaller footprint for greener media at scale. And this is something that's important to us and to many of our customers. So what are we offering today in the cloud? Right now, we offer 3 different flavors or sort of sizes of VPU-backed instances. We offer 2 varieties, which have 1 card alongside your virtual machine, and another variety with 2 cards. We are actively exploring additional shapes and sizes of both configurations of number of cards and virtual machine sizes. For now, we're, as I mentioned, focused on expanding in core compute locations worldwide. So our current footprint is with 2 locations in North America, Los Angeles and Miami, 2 in the APJ region in Chennai and Melbourne, and 1 in EMEA in Frankfurt in our expansion site there. Speaking of Europe, I would love to talk a little bit about this great example from one of our partners in Europe, G&L System House. They were actually one of those examples of a customer or partner who was using VPUs on-prem, and they're now utilizing them on the Akamai Connected Cloud for a hybrid VPU-based transcoding workflow. And that has been a real win for them. That has done a lot to bring down their cloud-based transcoding cost. Comparing to previously using a CPU-backed 32 gig premium Linode instance, where they could achieve 1 encoding ladder with 4 HEVC streams. Using our 1 card medium plan, they reached 6 encoding ladders, each with 4 HEVC streams. So let's quickly look at a demo of what this actually looks like in our sort of cloud manager interface. So as you can see here, up until now, instead of going through the whole process of trying to acquire hardware or colo, getting that shipped to you and racked and stacked, it's now this easy to just go into Cloud Manager, find the accelerated plan category, choose the correct size for your workload, and then to just run through sort of like any other of our cloud-based plans, or if you're familiar with using other cloud infrastructure as a service providers and hyperscalers, this is a process that's likely very familiar to you. So now, instead of having to wait weeks or months or even a year until you're actually able to access a VPU, you can create an Akamai Cloud account and do that in minutes. And if you're interested in learning more, you can go to linode.com/pricing to view our accelerated plan and pricing page, and find out more about creating a compute account there. And once that's created, you'll be able to monitor it from within your Cloud Manager account, just like sort of any other resource type. So moving ahead out of the demo, one of the main concerns that we heard talking to media customers about cloud transcoding was around egress costs. And this, I think, was a lot of what was driving buyers and customers into on-prem setups. And this is what we see as another advantage of the Akamai Connected Cloud. So in our VPU-enabled core regions, our egress pricing is actually just half a penny per gigabyte. And that's real industry-leading value for egress, especially when you compare it to hyperscaler pricing. So ultimately, what we want to do as sort of the cloud for media workloads is to help media organizations of all types and sizes to accomplish their goals. And we've identified 3 on this slide as the goals that kind of everyone shares, regardless of their content or their industry or their location. 1 is resource optimization. You want to get the most out of your technical resources. 2, reduce your cloud spend. Media organizations, I think especially, are sensitive to this and need to find ways to reduce spending in the cloud in order to continue scaling and remain profitable. This isn't just the case for plans you deploy, but also for egress. And we think that that outbound network transfer pricing is another real advantage when compared to the hyperscalers, as that pricing can just be astronomical. And again, that starts at just half a penny per gigabyte, applicable in all of our core regions where VPUs are enabled today. Also, increasing sustainability. This is increasingly a corporate goal, and this is definitely something that's top of mind for a lot of companies, Akamai included. We know how hard that is to do when deploying in the cloud, so we wanted to make sure that we had an energy efficient plan available to offer so we can pass that kind of sort of cost and energy savings on to our customers. So with that, I will pass things back over to Mark.
Excellent. Yeah. Well, thank you, Sarah. So I want to encourage, if you are near a computer and you can type, and if you have a question, please enter that into the chat window. If you're watching us on YouTube, if you're watching on LinkedIn, we're monitoring all the platforms. And so, go ahead and type a question in. We've already received, I don't know, 12 or 15. So we're going to get through those, but we're here to answer your questions. So with that, Sarah, are you ready? I've got a question for you.
I'm ready. Let's do it.
Okay, awesome. So Clay says, or asks, will Akamai be deploying VPUs across their entire contact surface? And then he puts in parentheses the edge. If so, what about billing? But why don't we focus on the first part of that? What are your plans?
Great question. So, as I mentioned, for now, we are focused on deploying in our core computing regions worldwide and expect to see more of those soon. That being said, we are exploring deploying in our distributed regions. It is absolutely something we're considering in the future, so stay tuned.
Awesome, awesome. A question came in from Daniel, who says, what percentage of streaming is migrated to the cloud? I suppose there's a couple different ways to interpret this question. Generally speaking, I'll go ahead and comment on it because we often find ourselves right in the middle of folks who are either wanting to migrate to the cloud, usually from some, on-prem infrastructure, or people who are actually moving off the cloud or a portion of their workflow off the cloud. So I think here's really what's happening. We touched on this, in the presentation. I touched on it. Sarah touched on it. The issue with video is that even though cloud costs scale linearly, and they mostly do, although sometimes, based on how you built your system, they can go nonlinear, i.e. your costs can increase more than you would expect or certainly want them to. But the issue is that, when you're starting a platform and you have 100,000 concurrents, or you have, some smaller number of viewers or concurrents, the cloud cost actually is, I think it's fair to say, affordable. And when I'm talking about the cloud, I'm talking about the big hyperscaler public cloud platforms, the 3 or 4 that we all know. So just in case, people are wondering, well, wait a second, aren't we here talking about the cloud? But, what are you saying? I'm talking about the conventional, I rent a CPU, I sign up for a 3-year commit and, and I run my business there. The problem is that at some point that scale just becomes unsustainable. And so I think what's happening, and I don't know if this answers Daniel's question, but what we're clearly seeing is that in the areas of video encoding and video processing, people are moving from sort of packaged solutions or even services, and they're starting to take control of that. And that's exactly what Akamai and NETINT is bringing to the market. This is a new way to think about sort of infrastructure as a service. And, over time, there's going to be a lot of additional capabilities that I'm sure Akamai is going to be adding to make it even easier. But it's that level of control that allows you to get your arms around cost It allows you to adopt standards and technologies faster. You're no longer reliant, on your cloud vendor. Whereas today, a lot of us are kind of reliant on the cloud vendor, and so we want to adopt a new standard, a new technology, a new codec, and they say, "Sorry, we don't support that." One popular cloud only just recently adopted AV1 live streaming, and it's AV1 only up to 1080p. So it's not even for 4K. So if you're sitting there saying, "Hey, I want to take advantage of this great codec," well, you can't do it. But with VPU, you can support AV1 up to 4K P60, and now you can do that on Akamai. So that's just kind of one, example there. Another question that came in, which I'll handle real quick, is how how to optimize VPUs for their maximum capacity without degrading quality. Now, this actually is a really, really fascinating question because when you're dealing with software, we all understand the balance of trading off the tools that you're going to use in the encoder, the way that the compute architecture is built, and then all those things. And there's of course other levers, like bitrate efficiency, and that's related to tools that are going to determine ultimately impact quality. The beautiful thing about the VPU, and this is a little bit hard, for our customers who are just getting started to wrap their head around, is that you no longer have to think about what's my density for H.264, and then how much does that density number go down if I want to encode HEVC? It's identical. So a single VPU on Akamai, the reference is it will do 32 1080p 30 streams. And that is AV1, that's HEVC, or H.264. So that's the beautiful part about having, or the beautiful thing about having dedicated hardware, dedicated silicon, is that these trade-offs that we're very familiar with largely go away. Now, you can still turn on tools. We have two pass, we have look ahead, we have some very sophisticated rate control mechanisms, which definitely will impact throughput. But still, the throughput is amazing. It's really, really amazing. Okay, here's a good question for you, Sarah. This is from Alexander, and he says, "Do you plan to provide VM plans with more than one or two NetInt cards?" I want to know the answer to this one.
I'll tell you what, I'll give our listeners a little bit of a spoiler, which is the
Ooh,
answer
spoiler.
yes. The answer is yes. We do. Stay tuned for more information and specifics, but we have more plans on the way with both more cards included and plans with larger VMs. So, again, stay tuned,
Yeah.
but you'll see that coming out later this year.
Amazing, amazing. We're really excited about that. Okay, so you heard it here first, everyone. Stay tuned. Okay, here's a question from Darius. Darius says VPU based live. So his question is live stream encoding quality versus efficiency. Again, this is a great question, and this is, those of us who have worked in software for the last 15 years with software encoders, and especially doing live encoding, understand very, very, very well. Like, you can have quality, but you're generally not going to get efficiency, or you can have efficiency, but you're not going to get quality, simply because the computing resources are finite. And it's so intensive to generate super high quality and turn all the tools on to get bitrate efficiency. So this person's basically saying, Darius says, okay, so how do you balance live stream encoding quality versus efficiency? And then the question is comparing to some popular commercial encoders. So very, very good question. I'll answer it this way. We have extensive benchmarks. We have a lot of data. Again, as an encoding vendor, obviously we produce our own data. but we actually mostly publish externally data that we have rights to, of course, from our customers. So you can go on our website, go on netint.com, and if you just go into the blog section, so go into resources, go to blog, and there's actually even a filter there at the top where it will basically give you a lot of the blogs and a lot of the reports. There's several done by Jan Ozer, who you might recognize him, very, very well known writer and codec and encoder reviewer in the industry. So I would just encourage that you go there, and then obviously you can reach out if you're looking for some more specific information. We are going to be publishing more of this in conjunction with Akamai. Some of it will just be, we'll be making this available together, data we already have, and there's some new data that we recently put together that we'll be putting out there into the market. Okay, great questions. What are the benefits of using Akamai and NETINT in live streaming concerts? So, Sarah, I think that's a good one for you.
Yeah, well, you mentioned that you have a number of customers who are using NetInt for concerts
That's
today,
right.
right?
That's
And I
right.
think,
Yeah, for live events, sports, we have, every weekend there are major sporting events that probably a lot of us watch that are being delivered or encoded with NetInt VPUs. So
and then couple that with the egress pricing on the
yeah,
Akamai Cloud platform,
right.
and I think that's a real kind of winning combination for
It's
especially live streaming.
Yeah, it absolutely is. Yeah, I think I'll just make a comment, and this is kind of an architectural comment. Is traditionally that there is a shift happening in how live events are encoding, the encoding architecture. So traditionally, what would happen is you'd have an on-prem contribution encoder, and that encoder would send, some sort of basically a mezzanine bitrate stream up to usually a cloud. And then in the cloud, it would get packaged, and it would, the adapted bitrate ladders would be created, and, whatever needed to be done to support, the devices that stream was going to ultimately be viewed on, that would all happen in the cloud. There's a couple problems with that. One is just by definition of costs of egress of moving those streams on and off these various platforms, there was considerable cost. That's one problem. Then you consider the latencies. So the industry more and more is talking about latency. Well, it's not really that efficient to take it from one architecture where there's latency on site of maybe 5 to 7 seconds in the contribution encoder. Then you go up into the cloud. Then by the time you process it and then you package it, and with the appropriate buffers, no wonder those streams were lagging broadcast by 30, 40, sometimes 50 seconds. So people have started to move away from that pretty quickly, is what we're observing. And what they're starting to do is they're creating the profiles on premise. So at the stadium, they're actually creating the adaptive bitrate ladders. Now, they still might be doing some sort of packaging in the cloud. They're not necessarily streaming. Of course, they're not delivering to the endpoints, delivering to the CDN directly from the stadium in most cases, at least that we're aware of. But what they are doing is they're creating the full adaptive bitrate ladder, and this is we're getting very much involved in these architectures and these new workflows, and that's where VPUs are just perfect for that. So brings a lot of advantages over the legacy approach, which most platforms are still doing today. Okay, so many questions here, Sarah.
I
Wow.
know. I'm a
Uh,
fan of it.
yeah. Let's see. Here's one, and I'm not sure. I know you and I reviewed this one. So this person asked, "What do you consider a workload at an efficient level?" to be? And we're not quite sure if you ask this question, feel free to reach out directly to Sarah or myself, and and if we don't answer your question, but Sarah, maybe from a cloud perspective and a compute perspective, you can just talk some more about the efficiencies of when you have something as powerful as this VPU engine, what you can then do with your VM.
Right. And so, as you mentioned, what we're really looking to do partially with our VM coupled with a VPU is to free up those VM resources to do other things. So, whether that's, codecs that aren't directly supported by the VPU or some of that packaging work, captioning and audio and other aspects that otherwise kind of create noise and increase the odds of
Yeah.
introducing latency into your workload and your workflow. That's where we're really looking to introduce additional efficiency. In terms of monitoring workloads at an efficient level, we do include a number of monitoring tools within our cloud manager, so you can keep an eye on your resource utilization as well.
That's great. Yeah. Well, good. Okay, bringing the plane in for a landing here. A couple more questions, and then we will wrap up. And Sarah and I, on behalf of Akamai and NETINT, really appreciate you taking time out of your busy day and schedule to join us. So Tim asked a question: can VPUs be ganged in multiples? Which I think is pretty clear. Like in a host machine, can I have multiple VPUs? And the short answer is absolutely. And in fact, this goes back to the question that was posed earlier that we answered about will there be plans with more than one or two VPUs? And Sarah says, yes, they're going to be considering, other options and configurations. But the short answer is yes, absolutely. So just to give an example, one very common server configuration is, there's multiple OEMs, Dell, Supermicro, HP, and others who have a 1RU chassis with 10 U.2 slots in the front. And this is a very common configuration. Everybody has their version of this server. They all kind of look the same too. That is a very, very common configuration because it's extreme high density. So that server loaded with 10 of our T1Us will encode 320 1080p 30 AV1 live streams or HEVC or H.264. And then because performance scales linearly, if you're to say, oh, but I need 1080p 60, well, you just divide by 2. So now you get 160 1080p 60 live streams. You might say, oh, but I need 4K P60. No problem. 4K P60 would be 40 4K P60 AV1. And I emphasize that because it's not, you can't even begin to get even in the same ballpark if you're doing this in software. So AV1, HEVC, or H.264, you can go all the way up to 8K. So, it's just, how many pixels. It's pretty simple math, actually. Again, go on our website. We can give you all those numbers. But absolutely. And if you have a machine, you can only fit 4 cards in, then, the math, is just based on 4 cards, instead of 10. So,
Mark, if you don't mind, I want to add for this question.
yes.
It's worth mentioning that on the Akamai Cloud, you can have a plan with more than one NetInt card. Today, we support up to 2. And as was mentioned, we're exploring additional sizes with more cards. But I just want to mention that those cards on your plan are dedicated resources for you. You will not
Mm,
share those cards, those VPU card resources with other users while you have them provisioned in your account. They are entirely dedicated for your virtual machine and your workload. It is not a sort of
That's right.
multi-tenant card configuration. And I just want to use this opportunity to
Yeah,
explain that important difference, since if you do use these on-prem, you can divide the VPUs up any way you
that's
so choose.
right. Yeah, thank you for pointing that out. That's something I don't think we really highlighted and really need to, because the industry has been talking for several years now about this hybrid approach. And a lot of vendors, especially if they come from the hardware space, I think both in an effort to remain relevant, have migrated to the cloud, but at the same time, their customers are saying, hey, we need the option to maybe flex into the cloud, or, maybe we primarily operate in the cloud and at times we go to on-prem for various reasons. And so it's very important that you have dedicated, those instances are dedicated to you. They're known, you're never going to run into an issue where, oops, sorry, you don't have capacity and you thought you did or you need it. So
Right.
that's,
And there's no noisy neighbor issue with
yeah,
sharing the GPU
yeah,
cards with
yeah,
additional guests. Those are
yeah.
entirely dedicated for you.
Entirely dedicated. Yeah, yeah, that's great. Yeah, thank you for pointing that out. And I really think with that we should go to our ending slide, because the punchline is 42 cents an hour for
And you can
VPUs on the cloud.